Chapter 4.2 Volume Studies. Traffic volume studies are conducted to collect data on the number of vehicles and/or pedestrians that pass a point on a highway facility during a specified time period. This time period varies from as little as 15 minutes to as much as a year depending on the anticipated use of the data. Traffic volume studies are usually conducted when certain volume characteristics are needed, some of which follow. First is the average annual daily traffic, is the average of 24-hour counts collected every day of the year. Then we have average daily traffic, which is the average of 24-hour counts collected over a number of days greater than 1 but less than a year. 3 is the peak hour volume, which is the maximum number of vehicles that pass a point on a highway during a period of 60 consecutive minutes. Then we have vehicle classification, which records volume with respect to the type of vehicles, for example, passenger cars, 2-axle trucks, or 3-axle trucks. Last is the vehicle miles of travel, which is a measure of travel along a section of road. It is the product of the traffic volume, that is average weekday volume or ADT, and the length of roadway in miles to which the volume is applicable. Methods of conducting volume counts. Traffic volume counts are conducted using two basic methods, the manual and automatic. Manual method. Manual counting involves one or more person recording observed vehicles using a counter. With this type of counter, both the turning movements at the intersection and the types of vehicles can be recorded. This figure shows the TDC-12 electronic manual counter, which may be used to conduct manual traffic volume counts at an intersection. The automatic method. Automatic counters can be classified into general categories, those that require the laying of detectors and those that do not require the laying of detectors. Automatic counters that require the laying of surface detectors, such as pneumatic road tubes, or surface detectors non-invasive such as magnetic or electric contact devices on the road, detect the passing vehicle and transmit the information to a recorder, which is connected to the detector at the side of the road. These are the devices used in automatic method. This one is the Apollo counter classifier, which is particularly suitable for cities and country. It is capable of obtaining per vehicle or volume data. The data collected can be downloaded to the Centurion CC software for Windows and a variety of reports obtained. While this one is the Traffic Eye Universal, and manufactured by Siemens, is an autonomous system that does not require any cabling. Its power is supplied through a zonal panel with a battery backup that can provide the necessary power for up to 4 weeks. Cordon counts. When information is required on vehicle accumulation within an area such as the central business district of a city, particularly during a specific time, a cordon count is undertaken. The information obtained from such a count is useful for planning parking facilities, updating and evaluating traffic operational techniques, and making long-range plans for freeway and arterial street systems. This figure shows such an area where the CBD of a city is enclosed by the imaginary loop A, B, C, and D. The intersection of each street crossing the cordon line is taken as a count section. Volume sections of vehicles and/or persons entering and leaving the cordon area are taken. The information obtained from such a count is useful for planning parking facilities, and so on. Screen line counts. In screen line counts, the study area is divided into large sections by running imaginary lines, known as screen lines across it. Traffic counts are taken at each point where a road crosses the screen line. Collection of data at these screen line stations at regular intervals facilitates the detection of variations in the traffic volume and traffic flow direction due to changes in the land use pattern of the area. Intersection counts. Intersection counts are taken to determine vehicle classifications through movements and turning movements at intersections. These data are used mainly in determining phase lengths and cycle times for signalized intersection, in the design of channelization at intersections, and in the general design of improvements to intersections. Pedestrian volume counts. Volume counts of pedestrians are made at locations such as subway stations, mid-blocks, and crosswalks. The counts are usually taken at these locations when the evaluation of existing or proposed pedestrian facilities is to be undertaken. Such facilities may include pedestrian overpasses or underpasses. Periodic volume counts. In order to obtain certain traffic volume data, such as AADT, it is necessary to obtain data continuously. However, it is not feasible to collect continuous data on all roads because of the cost involved. To make reasonable estimates of annual traffic volume characteristics on an area-wide basis, different types of periodic counts, with count duration ranging from 15 minutes to continuous, are conducted. The periodic counts usually conducted are continuous control or coverage counts. Continuous counts are counts that are taken continuously using mechanical or electronic counters. Control counts are taken at stations known as control count stations, which are strategically located so that representative samples of traffic volume can be taken on each type of highway or street in an area-wide traffic counting program. While coverage counts are counts used to estimate ADT using expansion factors developed from control counts. Traffic volume data presentation. Traffic flow maps are maps that shows traffic volumes on individual roads. The volume of traffic on each road is represented by the width of the band, which is drawn in proportion to the traffic volume it represents, providing a graphic representation of the different volumes that facilitates easily visualization of the relative volumes of traffic on different routes. This is an example of traffic flow map. Intersection summary sheets. These sheets are graphic representations of the volume and directions of all traffic movements through the intersection. These volumes can be either ADTs or PHVs, depending on the use of the data. Time-based distribution charts are charts used to show the hourly, daily, monthly, or annual variations in traffic volume in an area or a particular highway. Summary tables are tables that gives a summary of traffic volume data such as PHV vehicle classification and ADT in tabular form. This is the summary of traffic volume data for highway section. PHV is equal to 430 and ADT is 5,375. The vehicle classification of passengers, cars, 2-axle trucks, 3-axle trucks, and other trucks are also shown in the summary of traffic volume. Traffic volume characteristics. A continuous count of traffic at a section of a road will show the traffic volume varies from hour to hour, from day to day, and from month to month. However, the regular observation of traffic volumes over the years has identified certain characteristics showing that although traffic volume at a section of a road varies from time to time, this variation is repetitive and rhythmic. These characteristics of traffic volumes are usually taken into consideration when traffic counts are being planned so that the volumes collected at a particular time or place can be related to volumes collected at other times and places. Knowledge of these characteristics can also be used to estimate the accuracy of traffic counts. In this figure, monthly variations are shown, where there are very low volumes are observed during January, February, mainly because of the winter weather, and the peak volume is observed in August, mainly due to vacation traffic. This suggests that the traffic volumes taken either during the winter or months of January and February or during the summer months of July and August cannot be representative of the average annual traffic. So this is the figure which is shown for the monthly variations. But again, nga figure is dili ini Philippine based since watay winter and gone. So aga tarang makuan nga ni since we have both summer mo traffic jud nakadyo when compared to rainy seasons. In this figure, daily variations are shown. Since dili ni sa Philippines hikuha, this is so different kay if you notice every day murag nag-traffic jud sa Manila. So agani nga chart is not applicable in the Philippines since traffic permi. This is the hourly traffic variation, which agi mo makita dire is ang ilang peak hour is from 18 to 19 p.m., which is sample size and adjustment of periodic count. The impracticality of collecting data continuously every day of the year at all counting stations make it necessary to collect sample data from each class of highway and to estimate annual traffic volumes from periodic counts. Determination of number of count stations. The minimum sample size depends on the precision level desired. The commonly used precision level for volume counts is 95 minus 5, where the sample size is less than 30 and the selection of counting stations is random. A distribution known as the student's distribution may be used to determine the sample size for each class of highway links. Assuming that the sampling locations are randomly selected, then the minimum number of sample is given as this. So we're going to discuss it later using an example. Minimum number of count stations to determine a representative value for ADT on 100 highway links that have similar volume characteristics. It was divided to collect 24-hour volume counts on a sample of these links. Estimate the mean and standard deviation of the link volumes for the type of highways in which these links are located are 32,500 and 5,500 respectively. Determine the minimum number of stations at which volume counts should be taken if a 95 minus 5 precision level is required with a 10% allowable error. Solution. First, let's establish the data. Our significance level is equal to 100 since it's given in a problem that there is 100 highway links that have similar volume characteristics minus 95. It is based on a 95 minus 5 precision level, which we have a significance level of 5%. Our estimated spatial standard deviation of link volume is 5,500, and our minimum number of count locations is 32,500. These are both given in the problem. Next is the allowable range of error. RD is equal to 0.1 multiplied by 32,500. 0.1 because it's stated in the problem that it is required with a 10% allowable error, which means that we have 3,250 for our allowable range of error. Next is V, or the degrees of freedom, which is equal to n minus 1. So, which is equal to 100 minus 1 is equal to 99. Then we have the value for student distribution, which is equal to 1.984. Next is the student distribution, which is equal to 1.984. This value is found in Appendix A. I'll show it here. And you can find it by the degree of freedom, which is 99. So there's no value of 99, so it automatically fall on 100, and the upper part is 0.50 because in order to find the alpha, we need to subtract the confidence interval, which is 99 from 100. We have 1, and 1 over 2 is 0.50. Next is we have to solve for n. N is equal to 1.984 squared times 5,500 squared over 3,250 squared over 1 plus 1 over 100 times quantity 1.984 squared times 5,500 squared over 3,250 squared, which is equal to 11.27 over 1.1. Therefore, our n is equal to 10.1. Counts should be taken at a minimum of 11 stations. When sample sizes are greater than 30, the normal distribution is used instead of the student's distribution. So it's lesser than 30, therefore we could use this count for the minimum number of stations. Next is the adjustment of periodic counts expansion factors, which is used to adjust periodic counts and are determined either from continuous count stations or from control count stations. Expansion factors from continuous count stations are hourly, daily, and monthly. Expansion factors can be determined using obtained and continuous count station. Hourly expansion factors are determined by the formula HEF is equal to the total volume for 24-hour period over volume for F for particular hour. These factors are used to expand counts of duration shorter than 24-hour to 24-hour volumes by multiplying the hourly volume for each hour during the count period by the HEF for that hour and finding the mean of this product. Daily expansion factors. DEFs are computed as DEF is equal to average total volume per week over average volume for particular day. These factors are used to determine weekly volumes from counts of 24-hour duration by multiplying the 24-hour volume by DF. Monthly expansion factors are computed as MEF is equal to AADT over AADT F for a particular month. The AADT for a given year may be obtained from the ADT for a given month by multiplying this volume by the MEF.